In this example, we're going to look at a ball falling and use energy principles to kind of find out some more information about it. So for the first part, we're looking to find the speed when the ball has reached a height of 2 meters above the ground, considering that it started at a height of 4 meters. Okay, so just like the last ones, we're going to start by drawing our LOL chart. And now that we've drawn our chart, we're going to define our system. Okay, in this case, we're comparing the height of the ball and its speed. So our system would be made up of Earth and the ball. Now that we've defined our system, we're going to go ahead and track the energy. So at the beginning, we start with gravitational potential energy because we are at this height h above the ground. And as we fall, some of that energy will be transformed into kinetic energy. So let's go ahead and graph that here. So we'll show here gravitational potential energy. Let's give ourselves maybe 4 boxes of that. Okay, and no kinetic energy. Alright, as the ball falls, that gravitational potential energy is going to decrease as it's transformed into kinetic energy. Afterwards, when it gets to this point right here, it still has height, which means it still has gravitational potential energy. So now we're going to give it 2 boxes of that. And the other 2 boxes that we had over here are now going to go to kinetic energy. Okay, but I want you to see though, there's 1, 2, 3, 4 boxes here at the end, and there is 1, 2, 3 boxes at the beginning, 4 boxes at the beginning. So we started with some amount of energy, and we've ended with the same amount. This is a closed system, so no energy has entered or left it in this process. Now that we've done this, we can go ahead and write an equation for energy and use it to solve our problem. So now I've written the equation. We start with gravitational potential energy, kinetic energy, and then over here we end up with gravitational potential energy and kinetic energy. Now, beforehand we didn't have any kinetic. It was equal to 0 because it started at rest. It was dropped, which means that this is equal to 0. Okay, so that, and we'll call this height 1 and that height 2. Okay, so now we can go ahead and substitute our values. Okay, the mass is unknown, but you'll see that it's going to end up dropping out of our equation. Okay, height 1 is 4, height 2 is equal to 2 meters, and now we have enough information to solve for V. Here we've cleaned it up a little bit. The next step will be to subtract GH2 over to the other side and then multiply by 2. Okay, now we're going to multiply both sides by 2. We can actually factor out the G there as well. So we get 2G times H1 minus H2 equals V squared. So let's go ahead and substitute in the values and find out what V is. After you plug these values in your calculator, you're going to find that V squared is equal to 39.2 . And so we take the square root of that and find that that final velocity is equal to 6.3 meters per second. Okay, so what we've done is we've used our energy principles. We showed that the potential energy decreased partially, transforming some of that energy into kinetic energy. Okay, and we can use that concept to find out how fast it's moving after those 2 meters. Now you could also use kinematics equations here. We have an initial velocity, a final velocity. If we're in free fall with no air resistance, then acceleration would be 9.8, and you would hopefully end up with that same answer after 2 meters of falling. Now we're going to look at a second part to this question in which, at this point, instead of being dropped, the ball is thrown upward at 3 meters per second. So that's going to change one of our initial pieces of energy. Let's start by drawing our chart. Okay, so I've drawn the diagram here. The same system, the Earth and the ball. We have potential energy from gravity and kinetic energy before and after. The change this time is that initially it's moving upward. Okay, we have some V initial. Okay, which means that it actually has more energy now than it did before. So we can start here and say, okay, well, I had 4 boxes of this, and now maybe we have an additional box of kinetic energy from it moving upward. Okay, and as it flies through the air, by the time it gets to here, that potential energy will have decreased, which means if our system is closed, it will have transformed into, decreased, means it will have transformed into kinetic energy. So it's going to be moving faster. So we'll say that we lost 2 boxes again, which means now instead of 2 boxes of kinetic energy, we have 3, since it was initially moving upward. Okay, and then from here, all the problem solving is the same. Okay, write the equation out, substitute in the values, and then we can solve for what's missing. Just like last time, we're going to start with this equation. This time though, none of these starting values are 0 and none of these ending values are 0. What we can do is divide out the mass from each term, since they all have the same mass. Okay, and then I'll let you finish solving it from there.